Hello good day viewers. Here is another interesting exponential equation which is quadratic. We want to find a real value or values of x that will make the left hand side to be equal to 1. The equation is x squared minus 5x plus 5 raised to the power of x squared plus 4x plus 3 equal to 1. Remember we solved a similar question yesterday which involves logarithm. Alright, let's get started. Remember, if you have a raised to the power of b and this is equal to 1, there are certain conditions that will make this statement true. It's either if b, which is the exponent, is 0, but in this case, the base cannot be equal to 0, right? Any number to the power of 0 will give us 1, except if the number is 0. This is the first condition. And second condition is if the base is equal to 1, irrespective of what the exponent is. Exponent can be any real number. And also if the base, which is a, is equal to -1, but this time around the exponent has to be an even number. So these are the three conditions we are going to test. Let's start with the first one. When the exponent is equal to 0 and our exponent is what? X squared plus 4x plus 3. This quadratic equation can be factorized. Let us think of two numbers which we can multiply to get 3, but when we add them together we get 4, and the numbers are 1 and 3. Therefore this can be factorized as x plus 1 and x plus 3. This is equal to 0. If you set each factor to be equal to 0, it implies that x equal to -1 or x equal to -3. And remember that this solution is only valid if the base is not 0. So let us test these x values in our base. Let's start with -1. If we substitute -1 here, we have +1. -1 here, we have -1 times -5 will give us +5. And we have +5. You see, definitely this is 11, which is greater than 0. Now what if we test for -3? We have -3 squared here will give us +9. -5 times -3 will give us +15. And we have +5, which is definitely greater than 0. And hence, those two values are real values of x. So far, we have two solutions. The second condition stated that if the base is equal to 1, irrespective of what the exponent is, and the base is what? X squared minus 5x plus 5. Let us subtract 1 from both sides. We have x squared minus 5x. 5 minus 1 is 4. And this is equal to 0. This is another quadratic equation that can be factorized. Let us think of two numbers we can multiply together to get 4. But when we add them together, we get -5. The numbers are -1 and -4, right? So we have -1 here. And we have -4 here. This is equal to 0. If you set each factor to be equal to 0, it implies that x either equal to 1 or x equal to 4. We don't have to test for anything here because we say the exponent can be any real number. So we have so far 4 solutions. And the last condition stated that if the base is equal to -1, but the exponent has to be what? Even. So now let us set the base to be equal to -1. Let us add 1 to both sides. We have x squared minus 5x. 5 plus 1 is 6. This is equal to 0. This is another quadratic equation that can be factorized. Let us think of two numbers we can multiply to get 6. And when we add them, we get -5. And the numbers are what? -2 and -3. -2. -3, this is equal to 0. Set each factor to be 0. We have x either equal to +2 or x equal to what? +3. So these are the values of x, but we have to test whether they are going to set our exponent to be an even number. Let's start with +2. If x is +2, we have 2 squared 4 plus 4 times 2 is 8. Then we have +3. If you add these two together, you have 12, and 12 plus 3 is 15, and 15 is what? Odd number. And negative 1 raised to the power of an odd number will still give us negative 1, which is not positive 1. And hence we are going to discard that solution. We don't want it. So this is not a solution, but let us check x equal to 3. If x equal to 3, we have 3 squared 9, 4 times 3, 12, and finally we have plus 3. If you add 9 and 12, you have 21, and 21 plus 3 is 24, and 24 is definitely an even number, and hence we are going to consider this as a solution. So far we have how many solutions? We have x equal to negative 1, negative 3, 1, 4, and finally 3. So let me write all of them together. And therefore the set of values of x are what? We have negative 1, we have negative 3, we have positive 1, we have 3, and we have 4. These are the values of x that can make this equation true. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.